attended a session about 4 years ago at NSTA, and her name is Paige Keeley. And these techniques about formative assessment are so powerful, I can't even tell you. So this is volume 2, and I brought volume 2 because it matches my shirt today. So, but the one that I use quite frequently is, we call it predict, observe, and explain. So for example, here, I have olive oil and just water. And I haven't used this year, but it's coming up. And I really think about what are some of the basic questions in science. And one is, why does ice float? And today, I didn't do the demonstration for my kid today, but I said, you know what, I just need to get some information from you guys. And you wouldn't believe some of the misconceptions out there. It's just crazy. One kid is so confident that because there's air in the ice. If you look at ice really carefully, you can see these little bubbles of air in the ice. And then you see like little discussions in this corner and that corner. And then, you have some kids who are like, oh, it's the structure of the ice. And, of course, then there's density. But when you use some of these assessment techniques, so I have the kids predict, and then they do the demonstration, and they observe, and then they explain. But if you read these, there's so many of them in here that I always say it's not like a one assessment technique fits all, but there's different ones that fit better with different demonstrations. So I would highly recommend this book. Volume 1 first, and then volume 2 if you have time. Paige Keeley, Keeley. So, this is really simple. You take ice, of course. I have to take, what's going to happen when I put ice here. They're floating, great. But it's really nice if you make oil cubes. And then you ask them, what's going to happen when you stick an oil cube in the oil? And let's get out of the bag. These little stars. Little melted green bookers. I'm going to sacrifice for science and see if it's already I tried. So it gets a little bigger. And come on, baby. It should sink, but I try to bring them cold, but it didn't work out so well. But the question is, when you go on and ask them, why this happens, if it was completely solid, it drops like a stone. Right? And the kids, they don't know how to explain this. And it's really interesting to start off. I start off by bonding unit with this. And then we start talking about hydrogen bonding. And then I use the molecules to try to get at the particulate level and say, what is actually happening here? And why is the structure so important? And then, of course, we go on and start talking about, life on Earth, why is water so vital? My favorite are the insects, talking about, water tension, and then you go fishing in the winter, why do fish still live, things like this. But it makes such for a rich conversation in the classroom. And the longer that I teach, the more that I understand that complexity does not lead to deeper understanding. And some of the demonstrations that I see people doing, I don't understand them, or I can't explain them. And there's always a kid in there saying, Mr. Kobeck, why is it happening? And then I find me calling somebody from Chem West, or somebody from the Chicago, or Don Lee from UIC. I'm like, can you explain this to me? Because my kid asked this and I have no clue. So this is pretty straightforward, but the kids don't get it. But this is something that you can use, and it's easy, and it's super student friendly. You could even think about using it as little mini demos in the lab if you want to have the kids do it themselves. So I think that's cool. All right, so that's it.